How's it going, everyone? This is Mr. Oldenburg back with some more math stuff. Today we're going to do one of my favorite topics. I know he says it about every topic. I know I like math. We're going to talk about order of operations today because, believe it or not, you have to do things in a certain way to get the right answer. I want you to stick around after this part of the lesson's done because some of you had a little bit of trouble remembering adding and subtracting with mixed numbers, and I'm going to redo the do nows that we did this morning. So if you had trouble with that, hang back for another 2 or 3 minutes of that. So order of operations. A lot of times you might have heard your teachers from last year talking about, they changed the whole user interface on this, a little thing called PEMDAS. Now, PEMDAS does not stand for order of operations. PEMDAS is just there to remind us the order of operations. In other words, how we go about solving the problem. So, they said that 2 people completed this problem that's over here, and whoops, that's the wrong one. And they said that they got 2 different answers, and that's going to happen because of the way that we solve problems. A quick review of order of operations. The first thing you need to know is that just like reading, you are always going to work from left to right. And every time you change the sentence of the math problem, you're going to rewrite it and start at the left again. All right? Always left to right. So I'm going to solve this the wrong way first because I want you to see the difference. If I was just solving this from left to right, not even caring about the operations, I would start with 15 plus 12, and notice that I have a caret there. That's letting me know, hey, I'm using 15, I'm using 12, I'm adding them, and they're going to go away after this. And 15 plus 12 is 27. And then I would bring down the whole rest of this, divided by 3 plus 5. Then 27 divided by 3 is 9. Plus 5 equals 14. I'm going to put the 14 over here for now so we remember what that answer was. And now we're going to go back solving it the correct way. So, again, moving from left to right, but this time using the order of operations, we're going to solve it a little differently. To review the order of operations, let's talk about what PEMDAS stands for again. So, the P and the E stand for parentheses and exponents. So as I read from left to right, I'm looking for all parentheses and exponents. Not just parentheses, not just exponents, whichever happen first from left to right. Then I'm going to do the same thing with multiplication and division. And when that's done, I'm going to do all addition and subtraction. And you're going to see a lot of people get confused, and I'm going to show you in certain problems later on why. So for here, I see no parentheses and exponents as I look from left to right. Now I'm going to look for all multiplication and division. Well, I have a division sign right here. So this is going to be step 1 for me. 12 divided by 3 is 4. And I bring down the rest of the problem. And you're going to notice right away that I didn't start with the 27 that we did before because that wasn't done correctly in the order that operations are done. So now I have 2 addition signs left. I'm not going to get this wrong because I can't. 15 added to 4 is 19, plus another 5 is 24. And you're going to see how 24 is way different than 14. And it's all because we started with the division, not starting with the addition. Sometimes you might be asked to evaluate expressions. So Rebecca and Juan did this new problem 2 different ways because they got 2 different answers. One of them's right and one of them's wrong. Let's figure out where they went wrong, or where one of them went wrong. Well, if I'm looking at Rebecca first, I see 36 stays 36, so the plus sign stayed the same, and then I see a difference. She did 9 divided by 3 and got 3, and the times 5 stayed the same. It looks pretty sound to me because, again, I'm remembering all parentheses and exponents, all multiplication and division, then all addition and subtraction. And I'm going to stop right here for a moment because she divided, let me grab my pointer, she divided before she multiplied. And that's okay because it's all multiplication and division. not just multiplication then division. From left to right, whichever of those two happen first, it's okay to do. Now, if I look at Juan, the first thing I notice is Juan's first number changes. It goes from 36 to 45 because he added 9 first. And I automatically know that Juan is incorrect because Juan decided that he was going to add working from left to right. However, I can't add until after I've done all my multiplication and division. So Rebecca's correct because she did the correct order. You're going to get questions that look like this, where they ask you to insert parentheses to make the following statements true. Let's blow this up a second. So, if I were to solve this the way that it is, following the order of operations, I'm not going to get 6. I would do 5 times 2 first because multiplication comes before addition or subtraction. I'd bring the rest of the problem down. And then what am I going to do? So I'm going to see 13 minus 10 equals 3, which does not equal 6. So it can't be right. However, if I add parentheses, which is going to change the entire problem due to the fact that parentheses make something else happen first, it's going to change my answer. Now, the whole thing is you want to look at the problem as a whole, and you can use trial and error for this too. You could guess where the parentheses are going to go and then start figuring it out to see if you're right. Here, I notice that I want to get the 6, and at the end, I'm probably going to have to subtract the 10. I know that I cannot put the parenthesis here because I'm going to get a negative 8, and you don't want to negative anything in 5th grade. So that leaves me 2 choices. The parentheses here, which I wouldn't do because we did that first to see it was wrong, or the parentheses here. So I'm going to put the parentheses between the 5 and the 3, and when I do it, and I start with PEMDAS, I'm going to notice that my parentheses go first. I get 8 times 2 minus 10. Now I am all out of parentheses and all out of exponents. So now I move on to multiplication and division. And I have one right here. 8 times 2 is 16 minus 10, and that equals 6. It checks out. Sweet. Is this as fat as this thing goes? It's kind of annoying. Don't you love watching me erase? Isn't it awesome? So much fun. If only they'd add a quick erase ink button. If only. There's your constructive criticism, no recorder. We want quick erase ink buttons. Or at least I do. Alright. Now here they're only asking, hey, what operation do you do first? In class we solve these, but we're going to solve others in a minute. So let's talk about what we're going to do first and why. So, in this problem, I see that I have an addition and a division sign. Well, if I pay attention to the order, division always comes before addition. So, whoops! Hey now. We're going to divide first. In the next problem, I have multiplication, addition, and division. Well, by now, we've done this enough times that I know multiplication and division come before addition and subtraction. So I know that it's not going to be addition. However, I'm now stuck with multiplication and division. Well, which one do I do first? Well, like I said in the beginning, we are going to read from left to right always. So because of that fact, I will be multiplying first. In the next problem, I'm going to see that I have subtraction and addition, which go together. However, reading from left to right will not matter because I have parentheses, and parentheses mean that that's happening before anything. Down in number 6, now I have 2 sets of parentheses. Well, remember, we're reading from left to right, so the parentheses on the left are going to happen before anything, so my operation is subtraction. And then finally, in the last example, I have 4 divided by 2 times 8. Again, here, kids are going to make mistakes. They're going to say you multiply first because multiplication comes before division. It's not true. They go together. So when I multiply and divide, whichever one happens first to the left is what happens first. I'm going to divide first, even though the M is before the D. Because I could easily change this to PEMDAS if I want. All right, so the last couple I'm going to write because taking pictures takes too long. And what we're going to do is we're going to solve the first question we did. Just copying it correctly. All right, and then according to PEMDAS in the order of operations, I have parentheses. I draw my caret. 19 minus 5 is 14. I bring down the rest of the problem that wasn't used. All right, now I know I have multiplication and I have division up next. And as I look across from the left, I see a multiplication sign here. 14 times 3 is 42, plus the 4 is going to equal 46. All right, my next problem, I'm just trying to leave this here a second so that way you have it. Feel free to hit the pause button, guys. You'll get a good look at it. All right, and the next problem we did. Ooh, I'm running out of time. I got to pick you guys up at PE soon. Let's see, it's 8 times 6 minus 4 times 3. All right, I have no parentheses, no exponents. So now I'm looking at all multiplication and division. All right, first I have multiplication right off the bat. 6 times 8 is 48 minus 4 times 3. And yes, guys, I'm only doing one operation at a time because I don't want to get lost in what I'm doing. 48 minus 4 times 3. Well, I have another multiplication. And then all that's left is subtraction. Boom. Now in the next examples, they asked me to add parentheses to see if I can make the statement true. So, after I copy my problem, I'm going to talk about why certain things will or will not work. So, we have 30 minus 4 times 2 plus 5 equals 2. First thing I notice is that I have a 30 over here minus something, and I got 2 at the end. And there is a giant difference between 30 and 2. So I'm hoping to beef this up somehow, so that way I can take a bigger number away from 30. And if I look here, if I did 4 times 2 first, I'm going to get 8. But then 30 minus 8 is only 22, and then I'm adding 5. It's only going to make it larger and in the 20s. So my other option is 2 plus 5. Now if I do 2 plus 5 first, I'm going to get 7. And if I bring the rest of the problem down, I'm going to see that next, according to the order of operations, I would have to multiply. 4 times 7 is 28. 30 minus 28 does equal 2. And that's the way to get it right. Now here's the deal. If you didn't know and you couldn't think of that at first, it's fine. Trial by error. So try 30 minus 4 first. And if that doesn't work, then try 4 times 2. It's better that you at least try things, and then you're going to start seeing them as you move on. I'm not going to do that last one because it was so simple, and quite honestly, when you do the first 2 numbers as the parentheses, and they would have worked anyway because it was division and the other 2 are subtraction, there was no reason because you would have done it first anyway. It makes no sense. Why would that be an example book? I don't know. So as promised, let's talk quickly about your do nows. The first one that we had was adding 3.5 plus 2 3/4, and you can't add those horizontally, so we're going to rewrite them vertically. Then we noticed, hey, guess what? I do not have common denominators. I need a skeleton built. The other thing you need to remember, bring over your operation sign and your whole numbers. You will forget to bring those, as some of you did in class. Then I compare 4 and 2, and their common denominator when they would cross is 4. So I'm going to write my 4s. Whoops, not there. How do I get from 4 to 4? 4 times what is 4? 1. Whatever I do to the denominator, I do to the numerator. 2 times what is 4? 2. 1 times 2 is 2. Here's my new problem. I add 2 plus 3 is 5. 3 plus 2 is 5. Now, I notice I have an improper fraction. I need to make this a mixed number. How do I do it? I divide. So let's go back to blue. 4 goes into 5 one whole time with a remainder of 1. So this number is 1 1/4. And I have to add my old whole number to it, which is 5. 5 plus 1 1/4 is 6 1/4. You have to remember that you have to count your fraction and your whole number as separate entities at first, and then bring them together back in the end. And a lot of times you'll find that you guys will do one and not the other, and you have to come back to it. Let me add another page, and the other question we did was 10 minus 2 6/8. Well, can't do it horizontally. Let me set it up vertically. All right, notice my fraction and my whole numbers are in two different places. What are some kids going to think right away? Hey, if you're taking 6/8 away from nothing, you just bring it down. Not true. You can't take something from nothing, so I need to regroup. I'm going to borrow a whole from the 10. I am going to bring it to the fraction area. I made it 8/8. Why did I make it 8/8? Because I need common denominators, right? Well, if this is 8 already, I should make this 8. And as long as I put the same numerator as the denominator, it's still going to equal 1 whole that I took out. So it doesn't matter. As long as I just pick this and put whatever number that is in the numerator and denominator, I'm going to get it right. 8 minus 6 is 2. The 8 stays the same. 9 minus 2 is 7. You could leave it 7 2/8, or if you knew that 2 and 8 share a common denominator of 2, you would get 7 1/4. Hope you enjoyed this lengthy math lesson, and please study. Please. Thanks.